2018 relative velocity. A river flows with constant speed 4 meters per second between straight parallel banks, a distance 60 meters apart, and a woman can row a boat with speed 1 meters per second in still water. How long will it take the woman to cross from bank to bank, going across in the shortest time? Okay, here's our two river banks. Here's our woman. And if the river is flowing in this direction at 4 meters per second and she can swim at 1, if she goes in this direction here, really small angle, she's going to get dragged really way down the river. If she goes directly across, she's going to get dragged quite a lot because the speed is 4 times greater than hers. So she's going to need to go across in the shortest time. There's going to be an angle she's have to go at, and it's probably in this direction here. So she gets dragged this way to end up over here. So this is what we're looking at here in this question. She's going to end up down there. We have a distance across of 60. We have she can swim at 1. The river flows at 4. So let's have a look at a little diagram here for how long it will take her to cross. It's the first part is straightforward enough here because she can gain 1 across if she goes in the optimum angle, because she can swim at 1 in still water. So it's going to be 60 divided by her speed of 1 will give me the quickest time across, not the shortest time. So 60 seconds to get across to this point here, let's say, and she's gone slightly in this direction to get there. So let's do a bigger version of that diagram for part 2 here. We have it still 60 meters apart, and we're asked the distance traveled by the boat when it crosses in this shortest path. So this distance here is what we're looking for. We'll call that x. We can get the angle that she goes at in here. We can call this A. We'll call this one B. We'll call this one C. And we've got the river at 4 meters per second, and she can go at 1 meter per second. So we should be able to create some vectors here with my river. This is the velocity of the woman. She's going in this direction. So the velocity of the woman is that way. We have the velocity of the river is equal to 4I plus 0j. Let's deal in vectors. I'll do another version of this where we use the t method. We don't know the velocity of the woman, and the velocity of the woman relative to the river, she can go at 1, so it's her speed, so it's 1. Well, in this case, in this sector, she goes in this direction, it's minus plus, so it's minus 1 cos, and the angle we're dealing with is this right angle triangle here, and the cos is my I vector. So minus 1 cos A, and then plus 1, and that's in the I direction, and plus 1 sine A in the j direction. And we know that the velocity of the woman relative to the river is 1 the first one minus the second one. So we're looking for the woman here, the velocity of the woman. I'd have to bring the river to the left. It's the velocity of the woman relative to the river plus the velocity of the river. So I have to add my two vectors together to get the velocity of the woman. And that's going to be equal to 4 minus cos A. Put my 1 in if I wanted in the I direction, and just plus sine A in the j direction. So if we look at my vectors here, in the j direction is going to tell me the speed it's traveling at in the j direction, and it has to go 60. So distance divided by speed is going to give me the time taken to get there. Distance over speed is equal to time. So if I have the time taken to get there, so that's looking at my j direction going across here. And if we want to call this, let's call this y here. This distance that we're looking for in the I direction, do we have the speed that is traveling? In the I direction, the distance is equal to y. So y has to be this speed of 4 minus cos alpha times the time taken to get there, which we've worked out in terms of sine, 60 over sine alpha. So if we have y is equal to, we can do dy dx or do dy dA in relation to the angle here, and differentiating and letting equal 0, we'll get our max or min. It's a nice way to do this question. So if I multiply at the top 240 minus 60 cos alpha, we could leave the 60 outside. If you wanted to factorize it out over sine alpha, we create a quotient rule. So dy d alpha is equal to, on the bottom squared. On top we have the bottom by the top differentiated. Now cos goes to, I'll do an arrow to minus sign, so minus cos goes to plus sine. So we're going to have 60 sine alpha, cos alpha going to sine alpha, so 60 sine alpha, that's the bottom by the top differentiated, and then it's minus the top, 240 minus 60 cos alpha by the bottom differentiated, and sine alpha goes to cos alpha. So if I multiply this out, I'm going to get 60 sine squared alpha, and then we have this minus 240 by cos alpha, so we have minus 240 cos alpha, and then we have minus 60 cos alpha by cos alpha, which is, I've left out a minus there, haven't I? It's minus by minus and cos alpha, so it's plus 60, this minus and this minus, plus 60 cos squared alpha, and you can see your sine squared alpha and cos squared alpha over sine squared alpha, and if we let this equal 0, we're going to get 60 by sine squared A plus cos squared A minus 240, set that as 0, minus 240 cos A over sine squared A is equal to 0, and sine squared A plus cos squared A is equal to 1, so we got 60 minus 240 cos A. Now I can continue on, but the top has to be equal to 0 for this to be equal to 0, so we get cos A is equal to 60 over 240, which is 1 over 4. Now we had the distance y was 4 minus cos A, so 4 minus 1 over 4 times 60 divided by sine A. Cos A was 1 over 4, one over 4, so the square root of 16 minus 1, 15. Sine A is opposite over adjacent, opposite over hypotenuse, root 15 over 4. So 3 3/4, and actually this works out, it's giving me 60 root 15. 60 root 15 is what distance here? We were dealing with our angle A in here, but we got y over here, so we have this side, we have our 60, so we have our 60, what do we get here? 60 root 15. So this distance here, we haven't called anything z yet. Z is equal to the square root of 60 squared plus 60 root 15, all to be squared. That works out to be 240 meters exactly. So differentiation to do this question, we look at the t method in the next video.